Alright, I'm going to give you a quick overview of Vixen, how to set up a display, and how to do a simple animation. There are lots of tutorials out there on the web, so I'm just going to give you a very brief introduction. This is the starting screen for Vixen, which lets you do really two things. You can either create a new animation sequence or work on one you already have here, or you can set up your display over here, which is actually the first thing you need to do. You don't have any tracks to work on for your animation if you don't set up a display first. So let's click that. So this is what the display setup looks like. Mine's already done just because I've been using this for a couple of years, but I'll walk you through it and show you what everything means. I'm not going to go into a whole lot of detail, like I said, but what you have here are the elements, which are what shows up in your animation timeline. So these are just basically names you give to the different parts of your animation. And on the right, you have the controllers, the place that those animation sequences are being sent to. And in the middle is this box called patching, which connects the two sides. So you want to connect your elements up to some controller. So what I've done here is I've added elements for my 3 pumpkin mouths, my 3 pumpkin eyes, and then 2 sets of external lights being driven by the light box. And you can have more than this. This is just what I happen to have. So to add one of these, you need to pick the type of element that you're going to add. For us, it's just single item. Everything we're doing is really simple because we're not controlling some off-the-shelf commercial controller. So you click plus and you give your element a name. It can be whatever you want. If we had another light show, we could have light 3. Hit OK, and then it shows up here with a gray light next to it, which means it has not been connected up to a controller. So on the controller side, you need to add what you're actually going to be controlling in real life. So for us, we add generic serial. So I'm not actually going to redo that just because it'll mess up what I have. But to add generic serial, you just click generic serial from your pull down add menu and then hit plus. Let's actually try setting one up. Okay, on the right hand side you'll see the controllers. These are what are actually being controlled by the elements. On the left hand side, I've already set up generic serial for me. Let's go ahead and set up another generic serial. So from your pull down menu over here, we click generic serial and hit add. We'll give it a name. I'll call it generic serial 2 in my case, but you can leave it as generic serial if you want. Remember, we're actually setting up the ability to control our singing pumpkins from this computer that we're running Vixen on right now. You don't have to run your pumpkins from Falcon Pi Player. That's just a convenience so you can have everything running off of Raspberry Pi. You can run it off of a computer. You can run it off of this computer. You can put Vixen on another computer and run it off of there. It works either way. That's what I did for the first couple of years. I just wanted to make it all work off of something that fit in a box and had a web interface. So that's the reason for the Falcon Pi and the Raspberry Pi component. So once you click generic serial, you get this window that says controller output count. So we have 8 channels, ignoring the one I just added. So let's set it to 8. 8. Okay. And it gives you a warning that there's too many outputs. Some will not be patched. That means I've got 16 outputs defined here because I've already defined 8 and then 8, and I've only got 9 inputs or elements defined over here. So there's no way we can connect up 9 to 16. That's all it's saying. Don't worry about that. Okay. So if you click on this plus sign next to the generic serial that we just defined, you'll see our 8 outputs. Before we connect them up though, let's configure the generic serial. So click on generic serial and then go down to this gear and click configure. Okay. You'll need to set up your serial port here. This is the USB port to which your Arduino is connected. So you should be able to find that if nowhere else from the Arduino IDE. It shows you at the bottom which one you're connected to. The device manager will also show you that really when you click on this button, it'll only give you choices that are available anyway. So this shows COM1, which is what this microphone is plugged into, but we're obviously not sending things to the microphone, so I'll ignore it for now. Pretend I have an Arduino plugged in. I'd pick the port here. Baud rate is important. That's how fast we're sending communications from Vixen to the Arduino. That we defined in our Arduino sketch. So if you look at singingpumpkins.ino, you'll see there's a baud rate defined at the top as a variable. I have it set as 115,200 following Z particles example. Other values work. I've played around with it and tested it. They work fine. No parity, 8 data bits. You might have to play around with that if you set up a bunch of channels. Stop bits 1. Hit OK. Now we do want to send a text header. We set that up in our Arduino sketch as well. That just tells the Arduino sketch. It's a little bit of error checking. It says every time you see this text header, you know you're at the beginning of a packet of animation data. You're at the beginning of an animation frame. So we click that, and remember in the Arduino sketch we defined it as an exclamation point and a tilde. I'm sorry, a tilde and an exclamation point. So set it as tilde exclamation point. It really could be anything you want. Tilde exclamation point is convenient. Whatever, doesn't matter. Then hit OK. Okay, now we want to connect our elements to our controllers. When you get things properly connected up, you'll see green lights next to the elements and green lights next to the controllers. That says everything's patched. In the middle, these are our patch controls. I've already set mine up, and frankly I don't want to mess with it, but I can show you what it looks like. Really what you need to do is pick each one of these and patch it to one of these, and probably the simplest way to do that is to use the graphical view. So you click this graphical view radio button here, and then you can just drag a line from, you can pick one value on the left and one value on the right and draw a line between the two, and boom, you're connected. That's all you have to do. You can also just select all of these elements and all of these controllers, and then click patch elements, and it will do a one-to-one match if I remember correctly. If it's unclear, just look up the documentation. All you're really doing is connecting from here to here using this confusing looking middle window, but if you click graphical view, well, it's no longer confusing. So I select all of these using the shift button, and all of these, you can see the graphical view of the connection from each one of the elements to the outputs. So in Arduino terms, this says we're connecting whatever we put into our big pumpkin mouth element to the first bit in our serial output, and the bits are heading to the Arduino at 115,200 bits per second. Okay, that's all you need to do here. After that, what you need to do is click New Sequence. Now we're going to do our actual animation. Okay, so this should look familiar if you've done any kind of film editing, any kind of sound editing. It's really similar to that, and there's a lot of things going on here. Most of them you don't need to use for the simple stuff we're doing. In fact, we can simplify our view right away. We're not doing any kind of pixel lighting, which would be exactly what it sounds like, something that's rectangular like a display. So we can close that, make it go away, then it's not confusing anymore. You actually aren't going to be using most of these basic lighting things either. You can, I'll show you that in just a second. But the way this works is, this is just a timeline. You can just pull one of these basic lighting tools onto the timeline and then set how long it lasts. So the simplest one, this is confusing over here, but the simplest one is set level. that just lets you set the brightness that's going out to the Arduino. Since it's all analog, we can set the brightness of the lights, or what that means in terms of servo control, how far open the mouth is. So set level is the simplest one. We drag it onto our timeline. We're basically saying set the level for 2 seconds here. And the actual level you set is over here. It's marked as intensity. So this is a value that goes from 0 to 100. So that maps to from 0 to 255 in the Arduino sketch. Let's see. One of the other ones that's really convenient, especially for the eyes, or two of the other ones that are really convenient, are candle flicker. If we drag that onto the eyes, this just does some random brightness setting for you, and you can change things like how much the flicker flickers, how fast it flickers, all of that on the left hand side. And then to set the length of either one of these, the set level or the flicker, you just drag it. It shrinks, expands. Twinkle also is another good one that works well for the eyes. It's similar to candle flicker. It just has a lot more dead space in it when the lights aren't on at all. Most of the other ones aren't very useful for us because we're just controlling simple lights. We're not controlling chains of lights with a complex controller. And most of these aren't useful at all for the servos. The only one that's useful for us for servos is the set level. The other one that's really useful for the servos is pulse. In fact, pulse might be more useful to you than set level, because pulse lets you control a ramp for the intensity. So you can use this. Let's say you set it for, I don't know, 4 seconds, and you let the intensity ramp up from nothing to full. That would let the mouth of the pumpkin slowly open over the course of 4 seconds. If you want your animation to look more natural, you will probably be using quite a few of these pulses on the servo. So to set the ramp itself, you can just double click on this intensity graph, and this says, well, we want our pumpkin to go from fully closed to fully open. But you can set these endpoints however you like. I think you can even add, no, you can't add points, but you can set the endpoints exactly how you like. I thought you could add a point, but I guess not. Nope. Okay, you hold control to add new points on the grid. You can. Okay, so you can make this intensity curve pretty complicated and make the pumpkin mouth open, close, open over the course. But usually if you're going to do that, you might as well just use multiple pulses. Okay. For the lights, these are purely digital, so it doesn't really matter what you set here as long as it's over 50% intensity. So that will turn the lights on. Anything less than that will turn the lights off. Okay. So I'll show you a completed sequence. Let's just close this one. No, we're not going to save that. Let's open. This is Halloween. Why not? I'm going to shrink down pixel lighting over here. So this is what This Is Halloween looks like. I forgot to show you something very important. How to get your music into the sequence. So to put your music in there, you do Tools, Audio, Associate Audio. And it's giving me a warning because I've already have an audio file associated with this. But if I click yes, it'll just open a standard file dialog, and you can pick your MP3, MP4. It supports lots of formats. I'm going to cancel that because I already have it. Once you do that, you get the waveform for the song at the top of the window, which is really useful for the light show, especially because you can set the light show to the beat by watching the big high points in the audio waveform. It also was really useful for setting the mouth, because usually these blobs correspond to words. So you notice that a lot of times my Big Pumpkin's mouth goes with the big blobs. That's makes this really, really useful. Let's see. So you can play your sequence by hitting the play button. Now, if you have your Arduino set up to the side with the breadboard test setup that I have in the Instructables going, and you've compiled your Arduino sketch with testing set to true, then what you'll see is your LEDs, which correspond to each one of these channels, should blink in time and intensity with the channels that you've defined here. That's way more useful to me than having the actual pumpkin set up, because you don't have to watch those. You have something right in the corner of your eye to watch for the animation. It makes it go a lot faster. So once you have everything done, you can save your sequence. Now, once you are ready to send this to Falcon Pi Pro, what you do is sequence, export, then choose Falcon Player Sequence. See, Vixen guys know about Falcon Player already, so just hit Falcon Player Sequence. The timing is fine as it is. All of this stuff is fine. Just hit Start, and you'll get a dialog where you can export your FSeq file. This is the file format that Falcon Pi Player expects. So you can do the same thing in X-Lights. I'm pretty sure they know about Falcon Player as well. I just have a lot more experience with Vixen. Okay. So that should be it. That should get you ready to go. Once you're ready to go into the Falcon Pi Player, I've already put instructions on the Instructable for that. You just need to bring in that FSeq. The FSeq doesn't save the audio, it's just the stream. So you have to bring in the audio file also. And then you recompile. When you're ready to drive your pumpkins, you recompile your Arduino sketch with testing equals false. All that testing variable does is tell the output to pretend like there are no servos, because you're driving LEDs instead. And that's pretty much it. I know I didn't cover a lot of this, but I didn't aim to. I hope this is enough to get you started. I think I've probably said it already, even while I'm speaking here, but this part of the project it's fun, but it's also tedious, no doubt about it. If you can find someone else's FSeq file out there, or one of the other formats that Vixen can import, then by all means use it. It'll help you a lot. Like I said, in the Instructable, though, those are usually aimed at big multi-light displays, not at pumpkin animation or any kind of servo control. So you're going to have to tweak them. I mean, one of the things you'll have to tweak is the top level, because a lot of times people want the lights turned on all the way, but you don't usually want your pumpkin's mouth to open at full extension, except when you're doing something that's supposed to be really loud or really intense. The only other thing to point out is the animation tricks I used. I used a lot of cut and paste for the Lights 1 and Lights 2, because those do the beats of the song, which are really repetitive. You usually only have to set that up once, and then Control-C, Control-V all the way through your whole sequence. Really, for the pumpkin mouse, it's the same thing. I mean, how many times did they say, "This is Halloween, this is Halloween" during this song? Many times. So you just take this part where they say this is Halloween. Just like any other program, just click the beginning of what you want to copy, hold down shift and click the end of what you want to copy. Now you've got, see a highlight around all the things you want to copy. Control C, go over to where they say this is Halloween again, and then Control V it. And it saves you a lot of time. I mean, even if the lyrics are different, the mouth pattern for something that's just opening and closing is usually close enough that you can Control C, Control V, and then go in and clean up the mess. And that works pretty well. So it doesn't take as long as you might think. You don't have to go in. You only really have to go in for the first verse and the first chorus and do that by hand. After that is a lot of copy, pasting, and cleaning up. So hope that helps. Good luck.